All right, in this video, we're going to discuss the difference between physical and chemical changes. Sometimes this can be really confusing. So let's see if we can simplify it and point out some identifiers for when you're dealing with a physical change versus when you're dealing with a chemical change. The first thing we're going to do is define that a physical change, these changes they do not produce something new. Okay, so if some type of matter undergoes a change physically, you're still going to have the same kind of matter when it's done undergoing that change. For example, look at my reaction just below. We've got H2O, and this S here stands for a solid, so think of water in a solid form, also known as ice. And if it undergoes some kind of change here and becomes H2O, the L here denoting a liquid, so it melts from ice to liquid water. What you notice is that you still have the same substance, okay, the same chemical formula representing that you have the same molecule, water, before and after the change. So this is a physical change. Another example here, I have a picture of chopping wood. If you take a piece of wood and you split it into two pieces, each piece is still the same type of matter it was when those pieces were joined. If you split it into 10 pieces or more, each piece is still the same type of matter. Okay, so shattering, splitting something, slicing something, those are physical changes. The matter is undergoing physical changes. So words that denote a physical change might be words like melting, okay, or evaporating, or boiling. Also words like freezing, and you may be even to think of a few more. These all denote that the matter is simply changing its physical state, okay? So these all deal with transitions between solids, liquids, and gases, okay? Actually, I think a better way to probably represent that is to say these all deal with changes. I'm going to draw little arrows between solids, liquids, and gases. These are physical changes, okay? All right, let's think about chemical changes, okay? So if physical changes do not produce something new, chemical changes do produce something new, meaning the matter that you had when you started, after it undergoes a chemical change, will not be the same matter. You'll have a new compound, a new substance, a new element that you formed that you didn't have before. So look at the reaction I have shown just below here. We have CH4. This is natural methane, greenhouse gas methane, reacting with oxygen gas, creating water, H2O, and carbon dioxide, CO2. And you notice as you look at this, we had carbons bound to hydrogens in our molecule of methane, and then we just have oxygen by itself. And then when it undergoes a chemical change, when these two react, we have two totally new compounds that are formed on the product side, water and CO2. Now, in a balanced chemical reaction, what you should have is the same number and kind of atoms on both sides, okay? So you've got 4 hydrogens over on the reactant side, then I should have 4 hydrogens on the product side. Balancing chemical reactions and things will be a whole different video later on. But you notice here that the matter on the product side, when you're done undergoing the change, is totally new compounds, different than they were before, okay? So words that denote chemical changes. These will often be words like burning, toasting, okay, cooking. I'm sure you can think of some others, okay, maybe bleaching. These types of words denote a change in which the matter after the change is not going to be the same. It'll be a new substance that's produced, okay? And there's definitely more that we could think of. So hopefully that simplifies it a little bit. Mainly just ask yourself for any change, is my matter a new substance, or is it the same substance, just maybe in a different form, okay, or broken down into smaller pieces? All right, thanks for joining. If you like this, check out more videos.